Now that you've memorized your unit circle, you can solve some trig equations in radians or degrees without your calculator. So first of all, in this question, sine of theta is equal to negative root 3 over 2. Is root 3 over 2 on your pie plate? Yes. And if sine is your y-coordinate, when is your y-coordinate? What family do you have a y-coordinate of negative root 3 over 2? It's your pi over 3 family, or 60-degree family. So if you know your reference angle between 0 and 2 pi, here sine is negative, so you know from your cast rule it's got to be in quadrants 3 or quadrants 4. What are your family members in quadrant 3? 4 pi over 3. What's your family member in quadrant 4? 5 pi over 3. And this question is done. That's all the work you need to show. In fact, if you just wrote the answer, that would be considered fine as well. So if you recognize the value, you can find out what family it belongs to. And if you know what family it belongs to and you know what quadrant it's in, then you can just list the right answers in the right quadrants. So our second example. When is your x-coordinate negative 1? Right? Think of your unit circle. That's right over here. So what's our answer? At pi. No other work needed. So we can just pull the answer from our unit circle. Tan of theta equal to negative 1. What family, okay, what family, it's negative from my cast rule. I know it's going to be quadrant 2 and quadrant 4. What family do we have tan equal 1? Pi over 4. And so the answer is going to be theta will equal, in quadrant 2 you have 3 pi over 4. In quadrant 4 you have 7 pi over 4. If you have a question with one of your reciprocal trig functions, solving secant theta equals 2 is the same as solving cos of theta equals 1 over 2. 1 over 2 on your pie plate. Yes. What family is cos equal to 1 over 2? Your reference angle, your family. It's your pi over 3 family. What quadrants are we looking in? Well, cos is positive in quadrant 1 and quadrant 4. So theta will equal pi over 3 in quadrant 1 and 5 pi over 3 in quadrant 4. So one of the things that you're going to have is you're going to have your pie plate available. You're going to have that worksheet available. You can always check it. Usually for tests and quizzes, you jot something out. But I want you to practice to see if you can get those values right away. Maybe remember a couple of them. Maybe you remember that sine of pi over 6 is a half and cos of pi over 3 is a half. And that helps you figure out the other ones quickly. Something that you can figure out, how can I do this as quick as possible with mental math? Part D, the equation's a little bit all on one side, but you could use your algebra skills. Can you see that you could subtract 1 on both sides? Divide both sides then by 2. that you could get sine of theta all by itself? So I'll give you a 10-second head start on this one. Figure out the reference angle, then figure out the answers. Families pi over 6. Did you get quadrant 3 and quadrant 4? And so all of the types of questions that you've solved in the past can now become trig questions. So in the next section, we start looking at quadratic functions. If you can solve x squared minus x equals 0, you can solve cos squared minus cos equals 0. How would you solve x squared minus x equals 0? Factor out a common factor. Split it up. Either x is 0 or x is 1. How do we solve it with cos? Factor out a common factor. Split it up. Either cos theta is 0 or cos theta equals 1. Here, we have to keep going because we haven't solved for theta yet. We say, when is our x coordinate equal to 0? Well, at 0. No, my x coordinate's not equal to 0. It's 0 because it's my x coordinate at pi over 2. And at 3 pi over 2. When is my x coordinate equal to 1? That's at 0 and also at 2 pi, because the domain here that's listed included 0 and included 2 pi. Yes? At pi, cos is negative 1. So if we have a quadratic trig function, we have to use our skills in factoring first, and then look and see, are the values on my unit circle? Because then I can do it without my calculator. And if the values aren't on my unit circle, then I have to solve it the same way I would have solved back in grade 10 and grade 11 in trigonometry. So it really reviews our trigonometry from previous years and from now. How would you get sine by itself in this question? Add 3/4 to the other side to get the sine squared by itself, and then square root it. What do you have to remember when you square root both sides? Plus or minus. Square root of both sides, this will be the square root of 3 over the square root of 4, which is just 2. Is that on your pie plate? When is sine? When is the y coordinate root 3 over 2? Pi over 3 family. What quadrants are you looking in? Plus or minus? All of them. So you have the whole entire pi over 3 family. This is called a family gathering. If you have a trinomial, again, you can off to the side change it just to x's to ask yourself, what would I do if it was just x's? Could I factor that? And generally, I'll tell you that the factoring in grade 12 is generally nicer and easier numbers than the factoring you did in grade 10 and 11. In fact, if we factored this, some properties of factoring. Factoring is the opposite of multiplying things out. And when you multiply things out, this is what you would do, right? With whatever numbers are there. Whenever you multiply things out, the first ones always give you that first term. And so in this case, it has to be 2x and x. That's the only way you can get 2x squared. The last ones will always multiply to be that last number. And if my last number is 1, the only whole numbers that work out nicely would be 1 and 1. So far, I haven't actually had to do any thinking yet, because there was only one option for 2x and x, and only one option for 1 and 1. Now the question is, if I want to get a plus 1, I can get a plus 1 with plus and plus or minus and minus. Which does it have to be to get the minus 3x in the middle? They both have to be minus. If we check, my outside is minus 2x, my inside is minus x, that gives me minus 3x. Everything works out. So now, with the equation with sine, it's exactly the same. The only way to get 2 sine squared would be with 2 sine and sine. The only way to get my last term to be a 1 would be 1 and 1. They both would have to be negative to get a positive 1, and to make sure that I get that negative 3 sine theta. Now that it's factored, I can solve for sine theta here. I can solve for sine theta here. Is this on my pi plate? Yes. Pi over 6 family, which quadrants? Quadrant 1 and quadrant 2. When is my y-coordinate equal to 1? Pi over 2. So far, all of our examples have worked out nicely to be ones that we've had memorized. On your exams, sometimes they like to mix it up, have one that you have memorized and one that you don't. Sometimes we have equations that have both sine and cos in them. These cannot be factored the way that they are right now. But we can use one of our big ideas. We know that sine squared plus cos squared is equal to 1. And if I look at this equation, can you see that I could get cos squared all by itself by subtracting sine squared on both sides? If I rewrite the original equation, minus 3 sine theta.
Here's the interruption. Just one late announcement just before 3:30. Any teachers who have any sort of registration?
Now, I purposefully left out something. What didn't I write? I didn't write the cos squared when rewriting the original equation. Why didn't I write the cos squared? Because instead of writing cos squared, I'm going to write or substitute 1 minus sine squared instead. Why can I do that? Because my big idea says that cos squared is equal to 1 minus sine squared. Why would I want to do this? Well, now the equation that I have has only one trig function in it. And so if I distribute the negative, rewrite this in an order that I like and combine my like terms. I get something that I might be able to factor. What would you do if you can't factor it? Do you remember in grade 11, how do you solve when you can't factor something? Quadratic formula. They will put the quadratic formula they put back on your formula sheet so that they could put equations with sine and cos that you have to use your quadratic formula for. So we'll get those as well. But for right now, does this one factor? Well, if it does, the only way I can get sine squared is if it was sine and sine. And to multiply to get 2, I would need to get 2 and 1. Oh, did I make a mental math error? Did anybody notice it? Okay. It should be negative 4. Minus 1 minus 3 is minus 4. This is good because actually with the minus 2 it doesn't factor, so I would have had to use the quadratic formula. However, with the minus 4, it does work. Well, it could be 2 and 2, or it could be 4 and 1, but it's going to need to be 4 and 1. If I want to get a minus 3, minus 4 plus 1 makes minus 3. Now, sine of theta equals negative 1 is on your unit circle, but sine of theta equals 4 is not. So let's do the one that is. When is your y-coordinate negative 1? 3 pi over 2. Good. And so your y-coordinate is never 4 on your unit circle. So this may make you think this is a calculator question. So I'd have to go to my calculator to find it out. But if you go to your calculator and you try to do sine inverse of 4, what happens? Anybody try it? Okay, make sure that you're in radians. I'm in radians. I try sine inverse of 4. My calculator does not like it. Error. What's wrong with sine theta equals 4? How would you know without your calculator telling you it's an error that that's a problem? Well, maybe it's easier to see if I say, oh, 4 over 1. Where you're like, yeah, 4 is 4 over 1. But what's the definition of sine? Opposite over hypotenuse. Can you draw a right-angled triangle where the opposite side is 4? Here's my right-angled triangle. This side is 4. Here's my angle, and this side is 1. It doesn't work. The hypotenuse always has to be the longest. So this side you have to write and show that you know that it's not possible. You can't just leave it blank, because then they don't know if you've just blanked or actually know that it should be blank. So we need to write that it's not possible. Okay, we'll leave the last one as a warm-up for next class.